Hi everybody, welcome to Miss D's math page. I'm going to make this video quick because you're going to learn how to graph exponential growth. Okay, so these are our two little parent functions that we'll be looking at. And the first one is 2 to the x. So I like to make a table using these values. And then you take these values and plug them in for x. So 2 to the negative 1, that's 1/2. And you can't use a calculator for this, that's why I'm plugging things in. 2 to the 0, 1. 2 to the 1, 2. And 2 squared, 4. So as you can see, when we have exponential growth, the numbers keep getting bigger. So always use these numbers. Unless there's a transformation, then you might want to try something else. And I'll show an example of that. So now let's graph it. So negative 1 and 1/2 will fall in between 0 and 1. And then 0, 1, 1, 2. My hands look huge. And 2, 4. Why does it look like I have gigantic hands? All right, now when we graph exponential growth, not only are we going to graph it going in that direction, but what you also need to know is that it continues in that direction as well. Now what you'll notice is that it never is going to hit the x-axis, and the reason for that is because we have something called an asymptote. Now, I like to use a highlighter for my asymptote. Other teachers make you do dotted lines. But an asymptote is basically a line. It's like I call it like an invisible barrier. And it basically shows a line that the exponential graph is getting really close to, but never going to touch. And I'll explain the equation of that line in a second. So our domain, we have double arrows on the left and right, so our domain is, of course, all real numbers. Our range, if you start from the bottom, which is negative infinity, and you keep on going up, our graph gets really close to y equals 0, but it doesn't touch it. And because of that, we're going to use a parenthesis to represent the fact that we're getting close to 0, close to this force field, but not really touching it. And then the graph is really close to 0, and then it goes all the way up to infinity. So for exponential graphs, we have no brackets because we're not actually ever going to touch that lower number of the range. Now the asymptote is where the graph really gets close to. So if you were to continue this table going in the negative direction, the numbers would get smaller and smaller. It would go to 0.25, 0.125, and then it would get smaller and smaller. The numbers get really small, but they never touch 0. And that's because 0 is our asymptote. So we call our asymptote y equals 0. The reason why it's y equals 0 is because it's associated with our range. Now, the y-intercept is where the graph crosses the y-axis. It's always the one that starts with 0. So that is your y-intercept. End behavior basically explains, almost kind of like intervals. End behavior is basically like as x goes to negative infinity. So basically it's saying as x goes left, where does y go? So as I go to the left, how close to y is this getting? This is getting as low as 0. It'll never go past 0. So my end behavior on the left side would be 0. So if I were to take this skateboard and go backwards, what's the lowest or highest I would go? And it would be 0. Even though I don't touch 0, this arrow means that I approach it, doesn't necessarily mean that I'm touching it. And the right end behavior, and this should be a plus sign, as x goes to positive infinity, so that means as x goes right, so if I were to go from left to right, this graph is going to end up all the way at infinity. So basically what you're doing is splitting up the range. This would be your left end behavior. This would be your right end behavior. All right, so let's look at this next one. I'm not trying to have this be a super long video. This is the parent function of 3 to the x. So make a table using the same values. There's no rhyme or reason for these values. They're just the easiest to use. And then we do 3 to the negative 1, which is 1/3. 3 to the 0, which is 1. 3 to the 1, which is 3. And 3 squared, which is 9. Okay, so now we're going to plot it. 1/3 falls in between 0 and 1. And then we have 0, 1, 1, 3, and then 2, 9. Again, when you connect it, oh, that was ugly. Sorry. Kind of hard to hold this and record at the same time. Make sure you continue it all the way to the left. Okay. So our domain's going to be the same. Our range is going to be the same because the graph gets really close to that x-axis but doesn't really touch it. And that was a really ugly asymptote I just did. Just know that was only supposed to be for the x-axis. So my range is again going to be 0 to infinity. My asymptote is the x-axis, but I can't call it the x-axis because all asymptotes must start with y equals, because all horizontal lines are y equals, so that would be y equals 0. These always match. Now, here's a different one, the x-intercept, different from the y-intercept. X-intercept is where does it cross the x-axis? Well, if you notice, it never does. So we would say none, N-A, X, whatever you guys want to put down. Well, don't put X. Don't do that. All right, left end behavior. As we go to the left, this graph is going to get really close to 0. So the arrow means it approaches 0, doesn't mean that it touches 0. And then this should be positive again. So as we go to the right, this graph is going up to infinity. So you're basically, again, splitting up the range. So those are the parent graphs. So what I'm going to do is do these two, and then your assignment will be to do page 5 in class as an in-class assignment, and then page 6 for homework. All right, so let's see what happens when we transform our graphs. So we're going to do this the same way that we did your last test. So x plus 4, we're still going to do the opposite. Remember, anything next to x is always the opposite. So instead of actually going to the right 4, with this graph, we're going left 4. And then this here means that we are going up 1. So to all my values from before, I am going to subtract 4. And then to my y values from here, okay, remember we are talking about a parent function of 2 to the x. So 2 to the x is the parent function. I'm going to use these numbers and add 1. So I just took these numbers here and added 1 to them, and I took these numbers and subtracted 4, just like our last test. So our table now, when you work it out, no calculator, will be -5 and 1.5, -4 and 2, -3 and 3, and -2 and 5. So let's graph it. 1.5 goes in between 1 and 2. Okay, -4, 2, -3, 3, and -2, 5. So when you connect it, make sure you go all the way up. It will eventually go past the y-axis. It's not going past the y-axis. Now you'll notice I don't bring it down below 1. And why is that? Because we now have a new asymptote. Our asymptote is now y equals 1. Why is it y equals 1? Because remember, we went up 1. So if our original asymptote is at y equals 0, if we go up 1, now we have a new asymptote. And now you're going to learn where the asymptote comes from. It is the translation when you go up or down. So our asymptote is now y equals 1. And you see I used a different colored pen instead of a highlighter this time. So now instead of our range going from 0 to infinity, we don't even touch 0. It now is going to go from 1 to infinity. Domain is still the same. The y-intercept would be 0 and something, so I think I'm going to need to finish up this table so that I can get to 0. Or I can plug in a number in here that would give me 0. Okay? So I know if I were to continue this, 4 minus 4 is 0. And then if I were to continue this, I know that if I do 2 to the 3rd power, that's 8. Sorry. And then 2 to the 4th power is 16. So my y-intercept is at 0, 17. So sometimes you may have to continue the table till you get to 0 because the y-intercept always has to start with 0. That was an ugly circle. So remember, y-intercept always starts with 0. Left end behavior means I'm going to the left towards negative infinity. So as I go to the left, so if I were to slide down, this graph never goes below 1. So that means I'm approaching 1, not touching it, but approaching it. And look, it's the first number of my range. All right. Feel free to rewind this video if I'm talking too fast. I'm going to do this last example, and hopefully that's enough help to let you do page 6. So my transformation here shows that I'm going right 1, up 3, so I have a new asymptote, and I'm also reflecting over the x-axis. So because I'm reflecting over the x-axis, you know that all of these have to be multiplied by -1. Don't forget to do that. So since I'm going right 1, I have to add 1 to all of these. And then since I'm going up 3, after I multiply by -1, I have to add 3. So I get 0, 1, 2, and 3. And then here I get negative 0.5 plus 3, that's 2.5. Negative 1 plus 3 is 2. Negative 2 plus 3 is 1. And negative 4 plus 3 is negative 1. Oops, we haven't seen a negative yet. We haven't seen a negative in this row, and that's probably because we have a reflection. So if I were to rewrite this table, and I'm sorry I didn't rewrite it before, I have 0, 1, 2, 3 as my x values, and 2.5, 2, 1, and negative 1 as my y values. So let's plot them. So 2.5 falls right in between 2 and 5. 1, 2, 2, 1, and 3, negative 1. So watch how this graph goes. It's a little different. Now when you look at this graph, you're probably thinking that it looks like the graph is no longer a growth, but it actually is a growth. But it's a growth that's been reflected, okay? Because growth or decay comes from this number, not this number, not that number, or that number. It comes from that base. So if that base is positive, it's still a growth. So this is a growth that's been flipped. So that means our range is going to be a little different. Our asymptote is still the translation. So it would be at y equals 3. The range now, instead of going from 3 up to infinity, it's going 3 down to negative infinity. And remember, negative infinity is smaller than 3, so I must write that first. Don't worry about brackets because we don't use them anymore for this unit. Domain stays the same. Our y-intercept, yay, we do have a y-intercept. 0, 2.5. And now the last is your right end behavior. So remember, we're looking at our range. As we go to the right, where is this graph going to end up? Normally, we'd be looking at this number. But because we're going to the right and it's been flipped, our right end behavior is actually going to negative infinity. So basically, the range is flipped. Because normally we take this number, put it for right end behavior, and take this number, put it for left end behavior. But because of the reflection, the range is kind of flipped, and we got to put this answer here for our right end behavior. Just follow to the right and see where you end up. That's really what it means. All right, well, this video is 18 minutes. You could take a screenshot of this if you want, but your in-class assignment is to do page 6, okay? I mean page 5. Ha, just kidding. And you're going to do page 5, and then you're going to take a picture of it and send it to me, and I'll give you all the instructions on my MCPS classroom. All right, guys. Thank you very much. I will see you on Tuesday.